All right, looks like we're live. Welcome back, everybody. So today we're going to continue our saga into creating this Vimlike model editor in Rust. I'm calling this editor Red for you that don't know, as in Rusty editor for now. And so before we delve into what we're going to do today, let me give you a quick recap of where we were last stream and the things that I did off camera since then. So let me go back one branch to just LSP. And if I bring you guys to LSP mod, this is what we had, right? I create a couple of data structures to represent the request that we do to the LSP and the expected responses. And for you that aren't aware, the LSP spec, this is how it works in a nutshell. Let me give you a quick overview. So the interface we have with the LSP is basically a pipe. So we start a child process, and then we pipe. We use the standard out, standard in, and then standard error. So standard in, from the point of view of the child process running, let's say, Rust Analyzer, is going to be where we send our messages to. So we send messages to the process standard in, and then the process analyzes that message and optionally gives you a response through the standard out. Another thing that can happen is they can send you notification, as they call it, that are messages that were not initiated by us, the client, right? You can see on this diagram here, like when we open a file, we send did open. And since this is a notification, we don't expect any response, right? At a second time, I typed some text into that file, and then we sent text document did change. Once the LSP finished processing the file and came up with all the diagnostics for that file, let's say I have this error, I have this warning and whatnot, they give us this publish diagnostic message, and this is a notification as well. And then you go, like in this case, the editor uses, so you can see it on the left-hand side. So we did a go-to definition, right, from the editor. So we requested that. Okay, why don't you give me the definition for this text that is on the third line on the column, I don't know, 82, right? And then the editor goes and figures out, not the editor, the LSP figures out what's on that location and tries to go through its AST of the representation of your code and see who uses, who defines that thing, either a variable or a function or whatnot, and then returns you a definition with the specific file and position where that item is defined, right? I think it's pretty cool the way this takes place. Yeah, so this is not, in a nutshell, is what we implemented last stream. But the caveat was that everything that we're doing here is synchronous, right? It would be stop the world, talk to the LSP, and until I get a message back, we would not do anything, right? So that's a big problem. As you can see, we can render the editor pretty much unusable. And there was no support for like taking those messages from the client, the notifications that the server sends us or things like that. So I decided to rewrite this with async in mind and with this expectation that events can occur in different time frames and whatnot, right? So going back real quick to what we had at the end of last stream, this is what we had. Like I opened a process and started Rust Analyzer. Then I took std out, std in, and then I think std error as well. And I would synchronously send the request and expect the response. Send the request, expect the response, right? And we got this working last stream, but I figured out that this was not enough. So we did almost like a technical spike of the interaction between ourselves and the LSP, but that would never be the final form, if you will, of the solution, right? Okay, so that's where we are. And before we continue here, you may have noticed that I'm using a different shell. So I wanted to give a shout out to Erland on our Discord, and he was able to hook me up with a beta version of GhostTTY. So I was honored to be invited to be part of the beta testing for GhostTTY. And I must say that I'm very impressed so far. Coming from my term, it was almost flawless, not flawless, seamless. All the keys that I was used to, like Command D to split the terminal, Command Shift D, and then using Command then right bracket or left square bracket to go through the panels. So it was a joy. Hey, how are you, Swa? Yes. So, and then, okay. And the only thing that I really miss is having a visual scroll. And I'm pretty sure you should be able to enable this. I just didn't play with the settings yet, right? So, okay, so that's a quick recap and some items that I wanted to talk about. So let's talk now about this stream, right? Let me bring you to this other diagram that I put together. So this is what I'm thinking in terms of architecture. So we have our little editor here on the left-hand side. And my idea is to have Tokyo, multiple producers, single consumers. So one of those would be used to send the message to a given task. This task would be listening to this channel. And then whenever we have a new task, like let's say a request or a notification from the editor, we would send that to the LSP server through its standard in, right? So this is the first thing that would happen. And then from an LSP's point of view, two things can happen, right? They can either write something to standard out. If it's a response or a spontaneous notification, they will do that. We have our little receiver task that runs in parallel to the sender task and to the editor that would realize that we have something written to standard out, and it would put it on a channel here inside the LSP. And then our editor would have a place to be listening for those events. And then whenever we get a new event, it would process that event as it should. And the same thing would happen from an error perspective. If the LSP server sends something to the standard error, we're going to receive it and then handle it basically the same way, right? So this would be the architecture that I'm thinking. And then I put together a little flow here of one example. So you guys can, wrap your head like I did. That's why I had this diagram here to understand what's going on, right? The general picture of one scenario where we send a request and we get a response at a different event, right? Our processing ends when we send a message, and then we don't do any kind of busy waits or anything like that. So let me talk to that a little bit. Talk about that. So yeah, here you can see our editor. It's the user is in a given position on the editor, right? And it presses, let's say, GD to go to definition, right? We would trigger a message to the LSP client saying, I want to trigger the method go to definition, right? And then the LSP client, the LSP client would do the following. It would take the request, generate the message that it's going to send to the LSP server, and put the ID of the generated message here on a hash map with the action that should be performed, or I don't know how to do that yet, but I think with what we're waiting for, right? Let's say that ID1 is waiting for X, right? For an action X. Then it would put it here, and then it would send the message, like create the message, package it in JSON RPC, and send it to the LSP server, again, using the LSP server standard in. Okay, here is where we have a problem that our previous architecture would never be able to realize, and I'm going to show you that running right now because that's exactly the problem that I have right now that I'm trying to solve. So in between the go to definition and the response of this request, we get a notification from the server saying, I just finished running the diagnostics for the file you open. So here you go, have that diagnostics. And in my naive implementation, I would think that this is the reply for this request, right? And that's where, hell would break loose. So now we don't have that problem anymore. What we can do for the time being is completely ignore messages that don't have a counterpart, first, don't have an ID, or don't have an ID on this hash map where we keep all the things the editor is waiting for, right? So for now, we're going to ignore those. Okay, so now, so this is not get2. Yeah, here I have an error on my diagram. This would be ID2. And here, same thing. It's going to be ID2. All right. So let's say that now we completely ignored this server-initiated notification. And then at a later time, the LSP server responds our request here with, OK, here you are. If you want to go to the definition for that function, go to line Y, position X, right? So this would be step 4. And you can see I didn't even put an arrow here because this happens at a different time frame. And then what this would do is it would go and try to get this ID2 from the hash map and probably take it out of there. We could leave it there. I don't see a problem other than wasted memory. So we're going to figure that out because we're never going to have another message with that same ID as long as we're running the same session, right? So that's a non-issue. And then in this instance here, the LSP would realize that indeed we have someone that is interested on that ID2, retrieve the action that should be performed, and then just send it to the editor and request it to run that action, right? It would be like not go to definition response, but maybe move the cursor to file X, position X and Y, right? Something like that. So in a nutshell, this is what we're going for. I don't know if you have any comments about this. If you're watching this on YouTube and you have any considerations about it, leave a message. I'm not even sure if this is the best approach, something that I came up with from the top of my head here. All right, so after having in mind what I wanted to do, I created a new branch called LSP async. And if I open this guy, you see that now when we go to the main file, main is now async. and now it's a Tokyo main, right? So we're transforming our editor that was always synchronous into async. And then you see, if you read this code before, you see that now we're instantiating an LSP client, a new structure that I created, and we're calling the start method and awaiting. I'm going to show that in a second. And then the first thing that the LSP must do is to send an initialize message, receive the initialized response, and then send a final notification saying initialized to say that I'm now ready to have this exchange with you, LSP server, right? The other relevant difference here is that now I pass the LSP in when instantiating the editor. So let's take a look first at the LSP client, right? But before we go there, let's go to the top of the file. So I kept most of the, I did a little tweak, but I kept most of the data types that we had around the communication with the LSP. So we still have the requests. The only difference is now I'm using requests for both the request itself, but also for notifications. The only difference is that on the wrapper, I send an ID. So we have the request, we have a way to print the request. And then I have a response message that has the ID and the result, what the server responded with. I have the notification that can either happen from us to the LSP server or backwards, like from the LSP server to us. We have a case when we have an error. This is defined on the documentation. And then I have two wrappers around the messaging, right? We have the outbound message that can either be a request or a notification, and you can see we're using the same data type here, but the difference is how it's, let's say, the envelope that contains the request is either a request itself or is a notification, right? Okay, and then the inbound message, what we can receive back is either a message, meaning a response from the server, a notification, something that the LSP server started with, an error, if we have an error from the LSP, or a processing error. The processing error is any errors that we catch during the handling of the messages, and we need to inform the editor that what he wanted us to do didn't happen, and that's why, right? For now, it's a string, but I want to make it into a proper type later. Okay, that's basically the data types. And then we get into the start LSP method, which resembles a little bit what we had last stream, but it's only a resemblance. It's very different, right? So up until this part here, we do the same things with the difference that now we're using command from Tokyo, not the one from the standard library, because this one is asynchronous. And again, we take the standard in, standard out, and standard error, and take them here. So here we have 3 children. We have child standard in, child standard out, and child standard error, one for each one of those boxes that I had on my diagram here, right? And basically what we're doing now is we're creating 3 different tasks, long-running tasks. We have the sender task, the receiver task, and another receiver task to handle errors. So let's go through them. So this one here is the one that sends requests from the editor to the LSP, right? We're talking about this guy here. In this guy, what we do is we create a buffered writer out of the standard input so we can write things to that in a buffered fashion. And if you watched last video, that's what killed me last time. I had a buffered writer, but I never flushed the data, and then I kept knocking my head on my table here for an hour. And that was not interesting or pretty, by the way. But yeah, so in this case, I am flushing it. So that's the good news. But basically what we do, we get that buffered writer, and then we try to receive something from the editor. So the editor, remember that I said that it communicates with the LSP through this channel here. So you can think that this response TX, this request TX here is the way that the editor sends requests to the LSP, right? So we keep here blocked until there is a new request. And once we receive that, I log the message that the editor sent. And then I check, is it a request or is it a notification, right? If it's a request, what I do, I call this method called LSP send request, which basically assembles the message with the ID, the next ID, where we have an atomic usize to increase that atomically. Then we get that ID, put it on this package along with RPC 2.0, and then the request method and the JSON, the message JSON that we want to send, and we send it. And more important than everything else, we freaking flush it, right? So we make sure that it's written to the server. All right, and that can fail. And if it fails, what I do is I send back a processing error to the client through this receiving queue that the client has. When I say the client, it's the editor that the editor has access to. And in a very similar way, we have the LSP send notification that does the same thing, except it doesn't have an ID on the message envelope. And that's the first thing here, the sender task done, right? This is all the sender task is going to be doing throughout its life cycle. Okay, now the next one is the one that takes whatever the LSP server writes to STD out and tries to relay that to the editor. Let's take a look at this one. So same thing here. We create a buffered reader for standard out. We try to read one line, and we check if this line contains content length. That's the indication that that's the beginning of a new message. And then we try to parse this line to take the content length, which is the size of the body of the message, as a usize. And then if we're not able to do this, if we don't encounter the content length, what we do is we log it and we send one of those processing errors back to the server, to the editor, and we continue to wait for the next message. Then if we indeed were able to get the content length, we skip the next line, and we get the body with the exact size that was on the content length header. And then we read that, and then we send an inbound message. Oh, sorry. If we can't read that, we send an error. Otherwise, we parse the body. The body is JSON, so we parse that. We log it, and then we try to check the message, because going back real quick here to the overview, let's see if I can get you the specification of errors. Basic protocol. Yes. So what differentiates, I think, a request message from an error message? Let's see if I have, yes. So the difference here is the response error. An error message has not only the ID, but also this error key, right? So we check for the presence of that key here. And if we find one, we then get the code, the message that are also specified here. You can have those codes here and the message here as well. And we relay that back to the editor, and we wait for the next message from the server. So what's written here? If there's an ID, it's a response and not a notification. So we grab that ID, and now we just send it back to the client. So this is where I said that this architecture here is not implemented. That's what we're doing today. Otherwise, we find that there's no ID, so it has to be a notification, right? So we do basically the same thing, and we send it out to the editor. Last but not least, we handle a third task here that is dedicated to listening to standard error. This is a lot simpler. It just reads line by line. If there's an error, we relay that line to the client. I found out that that's mostly how the LSP conveys errors and handled errors outside of the message for error, right? If it's an unknown error or some unexpected situation, that's how they send us errors. And basically, this is what we're using for our infrastructure to send and receive messages to the LSP server. Let me see if there's anything else worth talking about here. Everything else is more boilerplate code, the way for the server having the LSP client to send a request, to send a notification, or say that it's ready to receive a response. We have the initialize method here. When we open a file, in our case, we only open one file so far. We send that message to the server that says, hey, I opened this file, and here's the contents of those files. So keep that file in mind, because we may do some processing with that file. And then what I was trying to implement was this go-to definition, right? And that's when I discovered that most of the times this was happening, right? I would send a request for go-to definition, and I would get this notification that had nothing to do with our request, right? And that's where I stopped. So I think the first thing that I'm going to do, let me think here. Yes, if I receive a response that is not the ID of the message that I sent, I'm going to ignore it for now, just to see if we can make go-to definition work. That's my first attempt, right? So what I'm thinking here is, when we send a request, I think it would be nice to get the ID of the message back to the caller. So I think we can do that because, let me see. Oh, that only happens when we send. Let me see. No, it doesn't. When do we assign the ID? Question. Oh, we put it in a queue. And then when it's taken out of the queue, we do the ID. So I think we need to change that. I think we need to have a method on request that stamps the ID to the request. Yes. And now we're going to have to differentiate request and the notification request. So let's do that first, because I think it's important for the sender to be able to determine what the ID of the message it sent out is. So where we had request here, I'm going to quickly copy this and create a new version along with the display. And I'm going to make this a notification request. Like that. Right? And then the request here, we're going to have ID, which is going to be I64. This has to be an option. No, it doesn't. Like that. Okay. I'm going to change the formatting a little bit to include the ID. So let's do ID. It's going to be something. Then self.id, like that. Good. Okay, now let's chase the errors. So when sending a notification, we want to do notification request. And we need to change the notification thingy to take a notification request, like that. Then LSP send notification needs to take a notification request, like this. I think nothing else changes. Now here, when we're sending the request, we're no longer going to generate this here, but rather we're going to do rec.id. We're going to do that on creation time. And this guy is no longer going to, oh, well, we can return the ID, which now is going to be rec.id. But, oh, we're shadowing the variable here. So let's do let ID equals rec.id. Do this. We don't need to clone it. Great. i64 has copy. This returns a U size, but you know what? Let's return i64. Like that. Good. Now let's see. Missing field ID. That's because we need to implement that field, the method that I was talking about. So let's go to the definition and implement request. And we're going to do, that's the beauty of Copilot. That's exactly what I had in mind. All right, so every time we create a new request, we're going to make it assign an ID. So let's go to the place where we were having that error. And instead of doing it like this, we're going to do request new. And then we don't need this any longer. And we just need to take out this brace here, mismatch delimiter. Why is that? Oh, we need and transform that into a like this. Arguments to these functions are incorrect because this takes a stir, not a string. And I think we're good. Okay, so I think we're back to a state where we can run. Okay, so now let's think again about the go-to definition. What I'm going to do, oh, I said that I was going to return the, so here we're going to return an i64 like that. And we're going to create this guy outside of the, let's do let rec equals this. And here we're going to send the request. And we're going to do OK rec.id. But I'm pretty sure it's going to complain about, oh, that's right. That's right. We need to package that in here, because otherwise we don't get access to the ID. Okay, moved value as I suspected. Okay, why don't we get the ID equals to rec.id this way? Hold on, isn't the ID copy? Do I need to do copy? Let's see. Oh no, it's not complaining. It is. Okay, let's delete to here, right? And now we're not gonna, what if we do this? Dereference, right? Yep, it can't. Okay, so what if we do clone here? Yep, okay. All right, request send, request. Let's put the ID here as well, like that. I like it. Okay, now, so we have the ID from the send request. We need to go back to go to definition. We can do here let ID equals this guy. Some response, receive, await. It's if it's a message. Oh, if it's a notification, we're already ignoring it. Okay, so I don't think we needed to do all this insane stuff. Okay, fair enough. Let's run. Cargo run source editor. Taking a little while to build. Interesting. Okay, so now let's find the line that I was testing this with was this one. Oh, we found a problem. If the cursor is outside of the, nice. Let me take a note on this. When I resize and the cursor is outside of the viewport, look what happens. Let me just open Notion real quick. Let me take note on that 1 second. Here, ideas, stream, Vimlike, model editor. Okay. Not here, here. So when the editor is resized and the cursor falls outside of the viewport, the cursor is moved to the last line of the terminal. This is a bug on the editor. Good. All right. Let's go to line 107. Let's go here to contents. But before we do anything, let's tail the log. And then if I do D, let's see what we get. Oh, and I forgot to put something here to protect you guys from not seeing the text. And this is what I'm finding. This is returning empty results. So let's figure out what we're doing here. So this is what I was talking about. This is the notification that we got that is not interesting, that we are not interested on. Oh, of course. So I don't think we're, yeah, look, this is going to become clear once you guys see this. Go to definition response. So the main problem here is that this thing is being handled as a response, which I think it is. Or is it? It doesn't look like this have an ID. But you know what? We can copy and paste it. Oh, we can't because this is not JSON. Okay. Request. Let's log this in a better way. Hold on. Let's see how we can log that on a better way. So we get response like this. Response.result. Yeah, if it is a response, we must have an ID, right? Let's see if we have an ID. All right, let's clear this out. Let's quit, run again. Go to line 107. Let's go to the end of the line, move back, clear our log, and then go to, oh, I said GI. Let me do it again. Go to definition, okay. So this is our response. Let's see, request to send, go to definition response 0. So that tells me that we are treating notifications as response. I don't think we have any code on the receiver end to check for that. So let's see. If we go to our LSP, sorry, not that, this one. LSP start. Start LSP. Start LSP. And we take a look at the tasks. This one starts with that. Incoming message. Oh, here it is. Oh, but wait a minute. That's super odd. You know what's even odder is this. It's not a response message. It's a notification. So you can even see that we have a hint from Rust Analyzer, the irony, right? That we were doing something wrong. So, and look, ID 0, what was I thinking when I did that? So this is a notification. There is no ID. There is just, let's see, method and params. Man, I was doing everything wrong here. So method is method, and we can delete up to the next P. And I think we're chilling, no. Oh, of course, we have extraneous stuff here. Okay, what about now? Expect the response message, found notification. Hooked on. Yes, because it's not message, it's notification. Okay. I think now it's happy. Let's see what happens now. We don't need to clear this. We actually need to quit this guy. Let's go again. Okay. Let's clear here. And let's go to line 107. And let's go to here. And then clear. Go to definition. Okay. Editor requested to send message, a request, and I'm not seeing the response because we received something else. So that's why we need to uncouple or decouple the response receivable from the sending of the message, right? So I don't think we can hack our way through this one, unfortunately. Okay, let's go back to the method. So it's go to definition. And we're going to end it here, right? We're going to end on the send request. And then, but before we do that, can we do this before? Yeah, I think. Okay, I'm going to do it this way, but I think there is a slight potential for this to be wrong. Here's what I'm going to do. I'm going to take the ID from the send request. So at that point, the request will be sent, right? And I'm going to put that ID only after I do this on this hash map that I'm going to create. But I'm going to keep a note here right now saying, fix me. We should first construct the request, take its ID, put it on our hash map, and then send it. This is a hack for now. There we go. So let's do let ID equals this, and let's put pending responses dot insert ID. And then I see a couple of different ways that we can do this. We can do what the editor was proposing and just say that we were waiting for a response of the type definition, and then handle that. Or we can be a little more aggressive and do the following. If you remember, if we go to the editor, one thing that we can do is like have an action, and then we could like have a method called move to XY, and we would just enqueue that. Oh, but we can't do that. No, we can't. That has to be what happens on the way back. That's right. That's right. So let's go back there. So pending responses dot insert ID. And I'm thinking that the send request can do that. This way we don't have this compromise here. I like that. Let's just say that the calling function doesn't even need to know about all this mumbo jumbo here. So here we have the ID, and then here we do that. So let's do that here. Pending responses dot insert. Yeah, that sounds a lot better. ID, and then let's add the method here just for us to know what happened. Okay, now we need to construct the pending responses, and that's gonna be a hash map of i64 and string. Let's import this guy. And here we're going to do pending responses hash map new. And here self. Expected string. Yeah, we can have this working. Not clone, to string. Okay, now if we go to definition, we have to handle this part here, right? Because this is what we are gonna do if we have a response for that. Okay. So now we need to go to the place where what's the problem here? Oh, of course, because this was waiting to be synchronous, right? So we no longer do this. What we do is return nothing. You own nothing, Jon Snow. You know nothing. Okay. That sounds right. Okay, and then send request gives us an i64 if we wanted to. So we could even return it to the caller. Yeah, why not? Don't think it's really necessary, but don't think it's a big issue as well. So let's do i64 like that. Remove the semicolon. Here we go. Okay. Now we need to start handling responses, right? I think that's what we need to do. Let's go back to start LSP response. No, this is sending messages. This is what we're looking for. Okay, so we receive the message, we assemble the message. Where is that being assembled? Okay, if it's a response error, we still have an ID, no? Hopefully we do. No, we don't. But, so we're gonna potentially have a few items in our hash map that are never gonna be cleared, right? Because if we don't get an error back from the server, what I think we need to do is do like an expiration of those messages in the future. But that's fine. Let me just take a look at the spec and make sure that we don't have that. Yeah, response error, we have the code, the message, and the data. Additional information can be omitted. Okay, yeah, it is what it is. So we have to handle that. Okay, let me just put a quick note here on the LSP client here. So to do, this should be a queue, should it? No. This, let's do a fix me. There's a potential for requests that errored out to be stuck in this map. We might need to add a timeout for requests. That's good. And remove them from this map. It takes too long. That's fine. Okay. All right, going back to our start method. Okay, so we either have an error, right? And we send it through this receiving channel, which I think we're going to have to be listening to on the other end. Otherwise, we send it to, yeah. So I don't think we need to change anything here, to be honest. No, we do. We need to know what to do, right? So, yes. I think this queue here, where we send the responses out. Okay, let's go to the editor and try to figure it out from there. I have an idea in my head, and I want to make sure that that's feasible. For that, there's an error here. Oh, go to definition. Right. Yeah, we don't need this anymore. Just like that. So my column, perfect. Okay, so now here where we do the events, let's go to run. And here is, yeah, this has to start being async, right? This, what I'm talking about, is the point where we wait for an event, right? Like resize, key press, mouse click, something like that. We need to start also taking in consideration that maybe we received a response from the LSP and we need to address that, right? We need to take a quick look at how to do async polling with cross term. So let's do that. So docs.rs, actually, let's see, cross term async. Yeah, that's nice. Okay, so here, what do we have? We have a select. I think this is exactly what we need to do. A select. Oh, what is this fuse about? But yeah, let's check the one for Tokyo. Yeah, you still need to fuse. Interesting. What is this delay? Where do we take into account this delay? Let's see where this is used. Nowhere? Oh, here. Oh, so this would be the interval that we check for new received messages. Interesting. And in this case, it's okay. Yeah, I think we can make this very low in our case. So let's try that. If we go here to our run, good thing it's already asynchronous. We still keep the loop. What we're going to do is we can do check bounds here unconditionally. And then we're going to do the same thing here. It's going to do let mute delay. It's going to be delay new. Is it fine 100 milliseconds? Yeah, I think for now we're going to do that. And then we can tweak that later. Let mute event is reader. What is reader? Oh, event stream. For sure, we don't have that. Let's add that here. Like that. Event stream. So I bet you that we need to add some features to cross-term. Let's see. Docs.rs, cross-term. Feature flags. Event stream. Yeah, it looks like we need event stream. Let's try that. Cargo, add this guy, and cargo sort. There we go. Okay, now do we have that now? Nope. Let me try quitting and coming back. Nope. Oh, there. No. Didn't work. Okay, so I think we need to go back to here, event stream. And what? Says it's already there. There's no... Ah, here it is, event stream. Maybe LSP is not liking that, so let's import that manually. So it's going to be cross-term event stream. This item is gated, but I just opened that gate. At least I thought I did. Oh, I'm stupid, am I not? You know what I did wrong, right? Yeah, I didn't add the feature. I just added event stream. Oh my God. Cargo remove event stream. Sorry guys, I'm getting old. Cross term with the feature event stream. Now we're talking. Okay. And now all of a sudden it's green. Gotta love that. Okay. So we're creating a new event stream like that. Perfect. There's no delay, no duration. So let's take care of that. Where's delay coming from? Futures and futures timer. I hate doing this and adding to our dependencies, but I think in this instance it's necessary. So let's do futures and futures timers. Futures, where do we get the dependencies for the examples? Futures core, dev dependencies, futures and futures timers. Okay. Cargo add futures timers. Timer. And cargo sort. Okay. Delay. No? Here we go. Futures timers, delay. Duration. Like that. And then event is reader next fuse. Reader next fuse. Yeah, I know. Probably this fuse comes from a trait. No, not even next. Oh, hold on. What is reader? Yeah, this guy's a reader. So we're going to have to extreme next and fuse futures next. There we go. Remove this mute. No, I won't. Thank you. Okay, so now we need to do that select. So select. Oops. And then if it's something, we're going to do handle responses from LSP. Maybe event equals event. Okay. Maybe event equals event. And here we're going to handle, yes, user input. Oh my God. Okay. And let's import select. Is it using Tokyo select? I hope so. No, it's using futures select. It says it's Tokyo, so should I trust this? I think so. Futures select. Oh, I did it wrong, didn't I? Okay, undo, undo. This one. The trait bound futures timer delay fused feature is not satisfied. Futures timers delay. Let's see if we're using the proper things from futures. Futures we're using select. Future X. Is that from future? Okay. And stream next. Then we have future timers delay. Where's that delay? Oh. Okay. Doesn't change anything. Are we using something in cross term that we shouldn't? No. Where's that streaming thing? Event stream, where's that coming from? Yep, same as ours. What seems to be the issue here? Let mute delay, let mute event. Is that a feature on the future timers crate, maybe? Future timers, where are you? No? Tokyo full, what version of Tokyo we have? I don't think that's the problem. Maybe it is. Let's check our cargo tunnel. Futures 03, futures 03, futures timers 3.0, yeah. In Tokyo, 136, in this case is 125. But I don't think that's coming from there. The only thing that I think about is maybe what we can do is create a new project. Cargo, new, test, cross term. Cargo, add cross term, futures, futures. Is it futures or future timer? Futures, futures timer, Tokyo. Tokyo full and cross term stream event. Let's see. Event stream, almost. Yep, forgot an F. Right, let's see. Main. Okay, there's a crate futures time. Timer. Did I do the same mistake here? No. So futures timer. Okay, so this doesn't give me a compilation error. Interesting. Very interesting. Aha, here. That fuse is missing. Good. At least we figured it out. Okay. So if we have an event, we need to do all of this. So I'm thinking about extracting this to a function. Let's see. Or maybe not. Maybe not yet. Let's do that. Let's just move it up and go with it. And I think this part can be kept here. Yeah, I forgot this first piece here. There we go. Then we paste it here. Yes, because we need to do that. If we look at our example again, here, match maybe event. Read my mind, Copilot, as per usual. Okay, now if we save this, we need to close one here. Hold on. Start all the way to here. Okay, so now we're closing it here. We have to handle the known case. Okay, let's see. Maybe event sum closes here. Right, so we don't need this one yet. Sum, okay. I must confess I'm a little bit lost. Let's see. Match maybe event. If you start, how do you fold things in Neo Vim fold? Fold methods, manual. Fold key Neo Vim. Okay, guess we're not folding. Whatever. Let's make this bigger. Okay, so here we have the sum. We open an if here and close it there. Open another one and close it there. And then we close the sum here. Oh, this is none, isn't it? Sum, okay. None. Some error, okay. Some error. Okay. Why is this not working? Oh, because we don't have E. So keep it like this. Okay. Cannot find value action start because that has been deleted, and I'm okay with that. And also start, we don't need that anymore. EV no longer there as well. Okay. Start, here it is. That's why. Okay, we had it in the wrong place. Okay. Resize, some action. I think we're good. Here we just gonna do like log handle event here. I bet you this is gonna print a lot in our logs, but it's good. Okay. Seems like we don't have any errors anymore. Let's tail our logs. We are already. Let's see if this even compiles. It does. There it is. Okay, so I think that's gonna work. So here we have to do self.lsp.handle responses. No. Let me see. LSP mod. Do we have a method for getting the next response? Let's see. LSP client, we have start, send request, send notification, receive response. So that's the one that we need to do. So let message equals, no, if let some message equals self.lsp.receive response dot await. Yeah, let's log it like that. Okay, let's see if that works. I think it did. Man, I hate this verbose log here. Received response. There we go. So we're in business. Let's see how the editor feels. Slow as fuck and doesn't even work. Huh. Okay, what if we make it 1 minute? 1 second? Will that change anything? Oh, I can't even quit it. Interesting. So can we, oh, we can't move panels around. Ah. I'm sure you can. I just don't know the keys in the key combo for that. I think we need to print this event as well. So log event, maybe event like that is fine. Oh, there's no resizing as well. Okay. Wait, didn't I resize? Yeah, you can resize. Definitely can resize. So let's do this. Okay, so we're not receiving messages. Let's type J. No. that's interesting because we are not hitting this piece here. It doesn't look like. Yeah, and we are re-rendering when we shoot it. So this should go back inside here. Or inside here, actually. There. I'm wondering if what we're doing wrong. Oh, we are doing this over and over and over again, right? Yeah. I don't think that's the issue, though. The question that I have is why is our cursor blinking? If we have an event, we do this. I am clueless. Totally, utterly clueless. We're not even passing by here. Okay, I think we need to start sticking some logs here. Let's see. Log, loop. And we saw that this was working, right? Log, delay. Now it stopped. We're not even calling this. Why? What was the last thing? Was a received response? This is blocking, isn't it? Yes, this is blocking. That's our issue. The method will sleep until a message is sent or. Okay, how can we check if there is a message or not? Let's see. Try receive. Yes, okay. This one tries to receive next value for instance if this method returns the empty error if the channel is currently empty. Okay. Let's take a look at try receive on Tokyo. Docs.rs Tokyo. And we're talking about this guy. Okay. So this is, okay. Match. And then if it's an error of this guy, none. But if we get another error, let's make this anyhow result, because this now can fail. Okay. Okay. This one. Okay, looks like that will work. Can do the same thing. Yes. Here we do this. Let's try it. Oh, except that we can't exit out of it. Let's see now. Still have the blinking thing, but oh, I know why we were blinking. This is a feature of Ghost TTY. Yeah. Hey, we're back in business, guys, and we're still receiving the messages. That's awesome. Okay, and we can even quit. Look at that. We can quit. Okay, what if we lower this to 100? Yeah, it still feels very usable. Or maybe not. I think let's try 500 here. I mean, even if completion takes 500 milliseconds, is that going to be a problem? Oh, and we're also logging, right? Let's not log every time. Oh, we're still running this guy. Okay. Let's remove this log. It's getting humongous. Let's try moving to the right. Yeah, it's a little bit sluggish, to be honest. But I don't know if it's the terminal or just the fact that we are processing that guy. Not sure. Yeah, but let's not worry about that right this second. Let's see if we can finally process the response. Okay. So the message that we receive here is an inbound message. But we were trying to change this to return also the... I think that's superfluous. I think if we do it here, what we can do is... yeah, because I think if we do an action there, we're going to have to do all of these things here. So this is render diff. Okay, let's create a function here called function redraw or redraw. Like this. Self.redraw mute buffer. And good. Because I think if we have a message here, we're going to have to do if exactly this. Then if we execute the action, yeah, we have to handle quit. Even though I don't think we're going to quit because of, yeah, maybe we will. We don't know. And then after that, we call redraw. Like this. And there was something else that I took from here. But there's some of the easiest to read Rust code I've seen. Really? That means a lot to me, man, because I am far from being an expert or anything. And I'll take that as a big compliment. Thank you so much. Because I'm struggling. I'm telling you, I'm struggling. What's the issue here? No method named handle LSP response. What is this? Handle LSP response. Oh, this is what we're trying to create. So can we create the method, please? No? Okay. Handle LSP response. Then yeah, I think we're not going to say response. It's going to be handle LSP message. Then this is going to be an incoming message. Like this, message. Oh. Mute self and then message. Which code AI are you using? Trying to compare several for work. I'm using the GitHub one, Copilot. Yes, integrated to NeoVim. I tend to disable this when I'm doing those sessions, and I forgot to do that today. So, but it does help a lot. All right, let's see here. If we go to LSP mod, isn't that incoming message? Let's see. Oh, maybe it's not public. Inbound message. There. Yes, sir. Oh, we need to pass the buffer and the current buffer, and that's what I was forgetting. Current buffer is going to be a buffer, render buffer, like that. We don't need split screens anymore. Cannot mutate Immutable variable buffer, but it's mutable. What are you talking about? Look. What the heck? Yeah, there's a lot of overlap on this case and this case. So I wish I could yeah, I think the right way to go here would be to take this as one event and handle it here somehow. Let me take a note on that. I think we should extract this match and have one branch that takes care of the case when we have a server message. Yeah, instead of trying to replicate the same logic, yeah, on the match above. Mute buffer, and here we have the current buffer. Oh, I know why. Is that taking the current buffer first? Yeah, so that what it was complaining about. Current buffer, and there we go. Cannot find value current buffer. Yes, because that buffer is here. We were doing that every loop. Let me see. GitHub, coder source, red. Let me go to LSP, source, editor. We were. Interesting. Oh, because, yeah, this thing was, that makes sense. Yeah, so let's do the following. Let's do this before the loop. Oh, no, we can't. Yeah, what we need to do actually is this. We need to clone it here, execute whatever we need to execute, and then redraw. And same thing here. Yes, I think that's going to work. Then handle, isn't that what I just created? Maybe I did. Oh, handle LSP message. Yeah, that's called message. Borrowing mutable. Why? Why? Was it saying you need to be mutable? But we are mutable. What are you talking about? Mute? No. Hold on. Cargo check. Oh, it's the inbound message that needs to be mutable? That's wrong. Okay. That should have been fixed. Let's see what errors we have. Expected inbound message. Okay, you got it. Current buffer is not being used, but it should because this is current buffer. Yeah. What else? Cannot borrow buffer as mutable. The binding is already a mutable borrow. That's right. What if I do this? So just undo and delete all of those things here. Like that. There we go. Okay, this is going to return none, and we do nothing with the message. So let's do something with the message. Match message. Inbound message. Message. Is it message when it's a response? Let's see. I think it's message. Then we have message again. And then inbound message notification message. And then we have inbound message error message, inbound message processing error. This is a string, so error message as well. Here for this last one, I think is easy because we can do self.lastError equals error message. Just like that. A message. And then this is going to be displayed at the bottom of the editor. Mismatched types. Oh, is there? Yeah, we need to make it some. Like that. To string. What's the issue now? No issue? No, there is something here. Mismatched types. Expected enum. Oh, we need to return an action? Yeah, so let's return none. Like this. This guy, none. Actually, this guy, to do. If it's a notification, we also gonna do to do. And finally, message. Now, if the message is a go-to definition, so if message dot method, yeah, so this is when we, yeah. No, I don't want to handle this right now. If this is a completion, let me see. LSP mod, no, not completion, go to definition, definition. Yes, text document, definition. Not println, log, got go to definition. Let's print out the range. So it's going to be message.params. Yeah, like that. No feud. Params on type response message. Okay, what do you have then? Response message. We have result and ID. Oh, wait. We don't know what the response message is for. If no, we're going to have to go back to our little hash map. So here, no. Response message. Yeah, we don't have that. We need to match by ID. All right. And as I was gone, I was thinking that, yes, we're going to have to revamp our LSP hash map. So let's go back to the place where we receive a response. Not there, here. So if we get, is this the LSP? No, I want to go back to the editor. Here. So we're not going to receive just an inbound message. We're going to receive more. We're going to receive what type of message was the one that initiated this response. So let's see, we have an inbound message. But in this case, we can have inbound message.message. Yes, okay. Let's go to the place where we send this, where we put this on the queue. So it's going to be something dot send. Processing error. So it should be around here. Let's see, incoming line, yes. A little further down, error, some ID here. So where are we putting this on the hash map? Let's do the following. Let's make this larger. Let's go to the first line here because we are, let's see where the hash map is declared. Oops. Hash map. Oh my God, hash map. Hash map. Okay, finally. Okay, it's pending responses. Next one. Okay, here's where we're inserting. So, okay, when we send the request, we do this. Perfect. Now, when we receive a response, we need to tweak a little bit the thing that we send back. So it's going to be an option of a string, I think, and the inbound message. Or even we can do like this to be more straightforward. It's going to be option string for now, like this. And we're going to do some. In this case, we need to look up the response, who we're sending the response to. So let's do that. So if Copilot is crazy, man. So does this give you the let? So what do we have again on the pending responses? Let's see. Oh, so perfect. We have the string that we need to send. If let some, this is the message method, is this. So we do return, okay, some, message, and some method. And in every other case, we return just a message like that. Here we're missing one of those. And here it has to be some and none. Here it has to be none and none. No, no, just that. Yeah, I think that's it. What is the issue here, my friend? Inbound. Oh, yeah, I missed. I forgot to make this a tuple. Now it is. Response message. Wait. Of course, because this is... Yeah, in this case, we're going to just do if matches message and inbound message dot message. We don't need to extract the contents of this enum like this. Oh, we do, because we need the ID. So let's go back to this. And this has to be an inbound message like that. We repackage it. Okay, what is message? Yeah. Unfortunately, we'll have to clone it. Oh, it doesn't implement clone? We'll make it implement clone unless we take it from the message, maybe? I don't know how to do that. So I guess I'll implement clone. Arguments are incorrect. Why? Oh, because, no. This is usize? It shouldn't be. What is usize? Is ID usize? Yeah, this is I64. Yep, I'm gonna do that right now. Clone. Okay, so let's see. Receive response. If we have an inbound message, we're gonna take that from the method from our little hash map that keeps tabs on that, and we're gonna send that. Perfect. So now, if we go back here, we don't have a method. That's right. But what is message here? Handle LSP message. I think, yes, it is wrong. So no, wait. What do we get when we do receive response? Yeah, we get this. So that's wrong. Oh, yes, message is a tuple. So it's no longer message here. It's going to be message and method, like this. Let some action is handle SP message. So we're going to send both the message and the method, like this. Go to definition, and we are expecting here method. It's going to be an option string, and I think we need to go back to the other one and not pass by reference like this. Perfect. So now if the method is this, let some method equals to method, we go in. If method equals this, then we do this, and we close here. Oh yeah, then we need to return the action. For now, let's return none for everybody, like this. And of course, we don't have params. Let's delete this. And this is method. And so, no, we don't need the method. We need the value from the message. So it's going to be message.value. Result. Is a private field. Let's go there. No longer. Okay. I think we're ready to test. But we need our log. Yeah, so this would be on the LSP mod. We were there already. Line 240. Just ID here. We don't need to convert anymore. Do we have any other issues? Yes. Oh, so this is a U64. What if we do I64? Okay. Any other errors? No. Let's see. Not yet implemented, of course, because I did a to-do on a notification and I forgot to fix that. In this case, we're going to do got an unhandled notification, like that. Log, got an error, that's fine. And then we need to do none, and we need to do none here. Perfect. Okay, so let's see. Let's go to line 107. Here, go to definition. Okay, so we got an incoming message and go to definition. Unfortunately, the command is not returning anything. I don't know what we need to do in order to make that work. Let's try to see, like, the editor is actually acting very weird. Let's see if we try to do, like, go to line.cars here. Go to definition. No, it doesn't return anything. Am I having the cursor pause wrong? Yes, cursor pause 35. That's wrong. That's very wrong. We're at line 108. So let's see. Go to definition. Here. XY. Ah, no, never mind. The request, I think, was correct. Let's see if we text definition. Did we log it? No. Let's log it. Request 3 sent. Oh, here it is. Character 28, line 108. I think that's fine. But it's actually we need to send 107 when we do this. Go to definition. Yeah, we are sending 107. That's fine. Character 25, we are at character 26. Still should have worked. So we're doing something wrong, right? We are requesting for text document / definition. We're sending params position, character 24, line 107. Let's read the documentation once again for text document definition. So if we go to language features, go to definition. Oh, we're not advertising that we have the capability. I think that's the issue. Yeah. Okay, so let's go back to our LSP mod. Let's go to our initialize method, initialize. And you know what? I don't want to send it this way. Oh, we already take JSON? Yeah, let's just do JSON. This is nonsense. Let's do here. So none of this shit. So we're gonna do capabilities. It's gonna be completion, and I also want to do go to definition. How do I do that? Server capability, registration options. Let's take a look at capabilities on our lifecycle messages when we do initialize. Client info, root path, capabilities here. Not workspace. Not window. What do we have in window? No. Show message. Oh, we need to support show message later. Wait. Text capabilities, text document. Is there something like document? Workspace. Code lens, semantic token, configuration, workspace folder, execute command, apply edit, file operations. No, text document. This is the one. Completion, signature, declaration, text document declaration. I think this is the definition, right? Yes, definition. So we need to pass in definition. Yeah, I don't think that's the problem, but let's try. So alongside completion, we're going to have definition. And that's going to be dynamic registration through, and what's the other one? Link support through. Okay, perfect. There we go. We don't need this BS anymore. Okay, let's see if that made any difference. Let's go to line 107. No, no difference whatsoever. Let's see. Can we, like, do we call one of our methods? Let's see. Let's see here. If I open the editor, here, let's see. Where do we call? So 1151. Let's go to that line. 1151. Where do we call is within viewport? Oh, there's a v height right here. Let's try that one. So here, what if we do go to definition here? Ah! Oh, why? So request ID 3 method text document definition params position characters text document is this guy, which I believe we did a did load for him. Oh, there's no find here. Yeah, I may need to do iterm. Let's copy that. Let's go to like VS Code. Here, let's see. Did open. Okay, text document, language ID Rust, and I trimmed it. I truncated it. So it would be nice to see this did open completely, editor send to. But I think that's correct. Or maybe we need to register the rest. What did we send? Initialized, initialize. We are indeed sending the completion here inside text document. So text document, and then it's, oh, hold on. Yeah, let me see where I'm truncating. Let's go to LSP again, LSP mod. And then what is the requested to send message? Requested here. So, oh, because it's display, yeah. So let's do this. It didn't like it because I did it wrong. Let's run it again. So let's see what we get. Editor requested to send message. So I sent a did open. The path is this, file source editor.rs. And I sent all the contents of editor.rs. So if we go to the very, yeah, there's a lot here. So let's not try. But let's continue. So then the server sent publish diagnostics, and oh, it still didn't do the go to definition, but I don't think that's going to change. So we were at line 11 something. Let's go to line 872. Here we have event to key action, go to definition. Let's see what it gave us. So this is my request, ID2, text document definition. Text document definition, which is explained here in language feature. Go to definition. Go to the definition request is sent to the client, from the client to server to resolve the definition location of a symbol at a given text document position. The result type location link got introduced in version 3.14.0 and depends on the capability text document definition link support, which I think we're sending. Yeah, that's one of the things that I wanted to check. So it's going to be text document. So we have capabilities, text document, definition, there, link support. There it is. Let me double check the initialize again. Initialize. So process ID. Oh, process ID is, no, okay, it can be no. But we're not sending it as no. Let's do that. Oh, not here. Rust get current process ID. Just standard process ID. Okay. We can send this. So let's see, where are we doing that on the initialize method on the LSP? initialize. Alongside capabilities, we have to do process ID, which is going to be this. One second, guys. Sorry about that. So let's see process ID like that. Let's continue looking at the document. Process ID client info is optional, but let's end it. Client info, name, red, version 0.1.0, like that. One more second. Sorry about that, guys. It's my mom. She always texts me when I'm streaming. All right, so now we're sending client info as well. Let's see. Locale. Root path. Deprecated in favor of root URI. Deprecated in favor of workspace folders. Initialization options. We're not sending anything. And then capabilities. Let's just make sure that I'm doing this correctly, and I am. Trace, and then workspace folders can be null, and it's optional. Yeah, I don't see, doesn't look like we're doing anything wrong here. Yeah, and that's all on the top level of the params. So let's give it one more shot here. Okay, all the exchange took place, and then let's go to line, what line was it? Here, 872. Let's go here and go to definition. Nothing. Let's see if we open, yeah, if we do this with NeoVim, it's gonna work. So let's do here, go to definition, yeah, instantly. Let's try the same thing with VS Code. I think I can enable the LSP trace. So let me see how to do that. So VS Code enable Rust Analyzer LSP trace. Trace, this one. So if we go to settings, JSON, yeah, it's already there. Let's open the project. So let's do code here. Let's do the following. Let's see. Rust Analyzer. There's supposed to be Rust Analyzer here when that option is activated. Weird. Let's open editor, see if that shows up. If we close this guy and go to output. No, here it is, it's trace. Perfect. So let's clear this. Let's go to line 572. Isn't it Alt G? No, I forgot how to go to a line. Go to line Control G. Okay, 872. There we are. Let's put the cursor here. Let's clear this again, and let's right click. Oh my God, I want to clear this. Go to definition. Okay, let's see. Let's see. So here, code action. Oh, let's see here. Definition. So line 871, character 23. What did we send? So, oh, but maybe we need to send the full path to the file. Maybe that's the issue. We're gonna check that. But yeah, line 871. Let's see what we sent. Line 871 and character 23. Interesting. Let's see. 872. Why 23? What? Is that the end of the... Maybe? Let's see. We're at position 32. What if I do go to definition from here? What do we send? 25. And what did they send? 23. Okay, so What if I go to the first character of this line and I do a code definition? Oops, subtract with overflow. Let's go to 1142 because that's an indication that we're doing something wrong. 1142 here. So it's CX minus 1. So I don't think we need to do minus 1 here. I think that's already 0 based. Let's try once again. 872. Go to definition from here. Number 0, line 871. 871, character 0. Let's do character again. Let's put at the end here. Go to definition. We did 26, but they did 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23. Maybe I was in that. So if we navigate back, how do you do that? Control minus, yes. Oh, yes, I was on the C here. Okay, so that makes sense. That makes sense. Yes, I was here, right? If I do GD from here, what do we get? 23. So the behavior is the same. The only difference that I can see is that we're sending the full path. So let's start sending the full path as well. The first place where we send that is on initialize. So let's go there. Oh no, it's on did open, which is right here. I have an idea to test. When I start this, I send just source editor. What if we do users, fcody, code, red, yes, like that. Let's see. So what did we send? Let's see here, did open. Did open, did open, did open, did open. Yeah, no, let me close this and run it again. Did open. Now we're doing the full path to the file, and I think the same would happen when so if I do 872 and I go here and I do, before I do that, let me trim this and go to definition. We got it. We got it. Oh my God, that's so good. Look at that. Here we have it. Nice, 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 nice. That was it. We needed the, ooh, I'm so happy. I'm so happy. Okay, let's make this into a JSON file. Oh, I can't. Okay, so object selection range. And so they told me on the documentation, let's see, go to definition. Here. So if we do language features, go to definition. Server capability, blah, 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 response. Result. It's either a location, an array of location. Okay. So let's start handling this guy. Let's see if we can do that. Let's go to, let's see, incoming, no. Where do we do that? It's handle LSP message here. We have a go to definition. Did we identify that? Yes, go to definition. It's an array, so we have multiple things. And I want to print it prettier so we can make sense of this. So let's create title here. Let's go to line 872. Let's go to event to key action. Let's clean this again. And let's go to definitions. Here we go. Okay, so now it's better. Let's see. So we have an array, or origin selection range. I think this is the item, right? It starts at 8 and goes all the way to 871. Target range, maybe this is what we're looking for. Character number 1, maybe not. Target selection range and target URI. Target selection range and target range. Let's see if I can see this here. Maybe, oh, maybe it's because we got the link. Yes. The full target range of this link. If the target, for example, is a symbol, then target range is the range enclosing the symbol, not including leading and trail white space, but everything else like comments. This information is typically used to highlight the range in the editor. Okay. The range that should be selected and reviewed when this link is being followed, the name of a function, must be contained by the target range. Okay. Then back here on that log that we captured, do we still have it? No, maybe this. Definition. But we can do that again. Hold on. I think it was here. Let's clean this. right key, go to definition. This is what we got. Oh, and they indeed highlighted this. So I'm going to advertise that I don't support links. This way we can go straight to the point, but not highlight it. And I will make a note of that. So let's go back to the LSP. Our capabilities here. Definition, dynamic registration, yes. But let's do dynamic link support false. Like this. Let's see what gives if we do that. Okay, line 872. Go to the right, clean the log, and go to definition. Aha, this is more what I was looking for. So we get range, and start. So we need to go to line 1163. Let's go to line 1163. 1164. There it is. Ah, man, this is going to work. We're going to have at least one LSP message that we support coming out of this session. I'm so happy. Okay, where am I? Did everything just froze on me? No, it didn't. Okay, handle LSP here. So, all right, and then the result, what we really need is if let sum range equals, no, not message result, range, let, yes, range start, then if let sum start equals range start, here, move to line +1 and character +1 maybe. I think our character is 0 based, so I think we're good. So we need to do move to and then generate variant. Let's go to it. Yes. Then we're going to have another issue. The expression has type. Okay. What's the issue here? This match type found enum. Wait. My LSP is crazy again? I betcha. Okay, so now we're going to have a problem with move to yes. So let's fill this match arm. Oh, good. Nice job. So let's find the go to line. Okay. Or no. We have to think because we're going to have to do the same thing we're doing here. So let's extract a method called go to line. Let's see. No, we will not be able to do that. So let's yoink. And let's create that method here. Go to line, self line, usize. Then we paste it here. This is going to be a self, mutable probably. And then this is going to use, going to return anyhow result bool like this. Like this. This is not async. Now it is. Then line doesn't need to be dereferenced. You might have meant to use the available field. Oh no, I need to get the buffer as well. So buffer is going to be mutable render buffer. Like that. Removing the borrow. Expected enum result. Font type, okay. This doesn't need to return. Yeah, but that's fine. Okay, I think that's fine. Let's do self.go to line like this. No? Expected 2 arguments, yes. This is buffer. Dot await, perfect. Found bool. Okay. So yeah, this doesn't have to return anything. It's going to be like this. This also like that. And finally this guy like that as well. Okay. So that's one problem gone. Now we need to do the move to. We're still having the issue where that method is absent. Yes. Let's give it one more chance to fill the match arms. No, it definitely doesn't like that. So let's do action move to X and Y. And this is that there. Oops. This is that there. Then self dot go to line buffer like that. And so there's another issue somewhere. This expression has type Saturday. It's okay. This is dot get. Let's change all of them. So here. So if we have this, then this, then I don't know anything, then this. We're going to replace that by, oh, and we need to capture this. No, maybe like this. There we go. And no, that's not working. Here, if I do it like this, what gives? Nothing. What if I do like this? No, like this. Yes, but I want to capture this. How can I? Nope, that didn't work. You know what? It's easier if I just do them. So take that out, insert, get, go to the end of the line, go to left, replace it with a close bracket. I did that wrong, but it's fine. Get. Okay, there. Let's test it. Time for the truth, my friends. Time for the truth. Line 872. No? No. It's not 872, I swear. Oh, we added a bunch of stuff, right? Yeah. Here. So handle waiting command, handle waiting command. So let's go to line 819. And let's go to definition from this guy here. Come on. Oh, but it did return the reference. It's saying for us to go to line 878. And I think I know why. It's because we're not handling whatever this returns. Let's see. Here, handle LSP message. Where is this being called? Oh, it is. Action mute buffer. Let's print the. Let's log the action. Log the action. So was it 819? Yes. Let's clean this. Go to definition. Go to definition. So result.get range. Oh, it's an array. Come on. So if let result equals to match message result. If this is some array value array ref array, if it's some value object ref object return object. This expression has type Insert the JSON value. Right, and mismatched type is expected in oh yeah, this was Copilot. Failed to resolve, yeah. Value array, so it's gonna be cert docsrs cert a JSON array. So what's the name of this enum? Cert a JSON value. Okay, let's try like this. Cert a JSON value. Okay, this is a value, and this is what? Oh, this is a map because it's an object. So yeah, let's do as object unwrap because I'm sick and tired of this not working. Non-exhaustive, yeah. If it's something else, let's do none. Yeah, we just return none. I like that. And then this is just result, like that. And now that should work, I guess. 820, it's not the place anymore. But let's see, self. So go to definition. Yes, we have go to definition, my friends. Nice, 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 nice. Let's try event to key activation. Oh my God, check that out. Isn't that cool? I think that's pretty freaking cool. All right, so mission accomplished, right? I think we managed to invoke our LSP server from our little editor. There is still a lot of things wrong. Like this is taking a lot of time. I'm doing things in a shitty way, I think. But this is what we wanted to accomplish at the beginning of the stream, right? So now the editor sends the LSP client saying, hey, can we go to the definition of this method? It relays that to the LSP server. But before doing that, it puts that on our hash map. Then the LSP server can spam us with other unrelated messages. We don't care. We just ignore them. But then later on, it returns, hey, this is the response for your request number 2. We take a look at our hash map. Do we have that? Yes, we do. Send it to the editor, and the editor does whatever action it needs to do once the LSP action is completed. Man, let me tell you, I'm pretty happy with the results. Hope you guys enjoyed the video. I sure did. This was one of the best sessions for me so far. If you like what I'm doing, my link, and you miss a few streams, if you're here in Twitch, you can find the link to my YouTube down in the description. We now have a Discord server where we can talk about programming, we can talk about Rust, whatever you guys are into. The link is down in the description. I would really appreciate if you guys join me there. And last but not least, if you're watching this on YouTube, of course, the link to Twitch is going to also be in the description. All right? Okay, thank you so much, and you guys have a good one. Bye now.